Hello, everybody. Welcome to Metric Hub, and we are preparing ourselves for the upcoming trial exam for the upcoming September preparatory examinations. So, guys, you should keep in mind that the preparatory examination has all the topics that you're gonna find in the final examination in November. Okay. So if you do well in the preparatory examination, you will also do well in the November final examination. Okay. All the topics, it covers all the topics of the year, the preparatory examination. Okay. So what we have here today, we're going to do paper 2. Okay. Mathematics paper 2. So this paper, this is September 2025. So you can see the marks is 150. 150, just like the final exam. So it's from Free State. This is a Free State paper. It's from Free State province, and it is September 2025. Now, okay, let's get into the paper. Okay, so you can see it's a 3-hour paper. So these are the instructions here. Number 1, this question paper consists of 10 questions. Answer all the questions in the special answer book provided. Clearly show all calculations, diagrams, graphs, etc., which we have used in determining your answer. Answers only will not necessarily be awarded full marks. You may use an approved scientific calculator, non-programmable and non-graphical, unless stated otherwise. If necessary, round off answers to 2 decimal places unless stated otherwise. Then they say what? Diagrams are not necessarily drawn to scale. Number the answers correctly according to the number system used in this question paper. An information sheet with formula is included at the end of the question paper. Write neatly and legibly. Okay. So now, is question 1 is about statistics. Okay. They say the box and whisker diagram below shows the distribution of test scores obtained by a sample of students in mathematics and science. Okay. Use the diagram to determine the following: the range for mathematics 1.1. How do we find the range? Isn't it you must say? So for mathematics, we say the highest value, which is over here, minus the smallest value, which is over there. Okay. So we can see here that what? The smallest value is what? Is 10, isn't it? And then the highest value, this side, the highest value is going to be, so it's 2, 4, 6, 8, 10. So yes, it's going to be 98. Okay. That is going to be the highest value. So then the range here, isn't it? For the range, you must say the highest minus the smallest. It's going to be 98 minus 10, which is going to be 88. And then the median for science. How do we find the median? We must go to science, which is the one on top there. So the median is here, isn't it? So we can see we have 60. This line is 60, meaning the next line, because each successive line is 2 units. So the next line here, which is Q2, is going to be, we add 2, so it's going to be 60 plus 2. So then our median here will be, is 1 mark, okay? Is it 62 or 52? No, it's 50, okay? It's 50, not 60, because it's 10, 20, 10, 20, 30, 40, 50, okay? Yeah, so it's 50 here. So it's going to be 52. It's 1 mark. So you can just write just like that, 52. And then the interquartile range for science, isn't it? The interquartile range, we must say Q3 minus Q1. So we look at science and we find Q3 and Q1. So for science, so where is Q3 for science? Again, we look. Q3 is going to be where? This is Q3. And this is Q1. So if it's 2 units, it will go from 40, it's going to be 42, 44. So it's going to be 70 minus 44. Yes, for science, it's going to be 70, which is here, and then minus 44, because it's not exactly at 40. 70 minus 44. 70 minus 44 is going to be 26. And then they say, which examination was easier for the students? Motivate your answer. Which examination was easier? Okay. So, okay, we must look at the data, isn't it? We must look at the box and whisker for each. So we can see that the values are higher. Okay, for what? For science. Q1 is higher, the minimum value is higher, and Q2 is also higher than mathematics. Okay. So which examination was easier for the students? For 1.4 here, the answer is going to be we're going to say mathematics. And then they say we must motivate your answer. So you must give a reason. So the reason is the minimum value as well as the median. Oh no, it's science, sorry. I meant to say science. So the answer here should be science, not mathematics. So the minimum value as well as the median is higher. Is higher for science than mathematics. Than mathematics. So that's the reason. Okay, the minimum value and the median for science compared to mathematics is higher. Okay, so it means the science examination was easier in comparison. Which examination has a weaker spread of scores? Okay. Which examination has a weaker spread of scores? Justify by giving two reasons. Okay. So, good. 1.5. Okay, so a weaker spread is going to be what? Mathematics. Okay, it's going to be mathematics, and then they say give two reasons. Okay, they say justify your answer by giving two reasons. So, okay, we can look back at the what? The question, okay. They say, we found the range for mathematics, 88. Okay. So, the range here is 88 for mathematics. And okay, so if we compare, we can compare the two ranges. Okay. So mathematics has a range. So mathematics has a range of 8 and IQR, the interquartile range of 40. Science has a range of 58 and IQR of 26. So that is the reasons here. We compare the what? The range and the IQR. You can see that for mathematics, they are higher. And then for science, they are lower, both values. So that is why we say it has a weaker spread of scores. And then 1.6, they say if a learner from the science sample is selected randomly, find the probability that the learner achieved a mark greater than 70%. So this is science, okay? Okay, so 70% is the third quartile, okay? Greater than 70% is going to be is higher than Q3, meaning it's the last quarter of the what? Of the data set. 1/4 is 1/4 in it, which is 25%. So you can say for 1.6 here, we can say 1/4 or 0.25 or 25%. That is the probability that we're going to have here. So, okay, statistics question. So this question was 10 marks. So let's go to question 2. Question 2, they are asking, refer to the statements below and answer the questions that follow. A least squares regression line, a line of best fit, has an equation y minus 49 minus, or y equals to 49 minus 3x. There is one outlier that has been identified as 9 and 4. The correlation coefficient is very strong. Okay, now They say if the outlier was removed, would the correlation coefficient be stronger? And then they say explain your answer. If the outlier was removed, okay, they say explain your answer. So yes, we know that if we remove the outlier affects the what? The average, and it also affects the correlation, isn't it? So yes, that's the answer. Yeah? So if we remove an outlier, it will improve. It will improve the overall correlation. So is the correlation coefficient closer to 1 or -1? Explain your answer. Okay. So okay. So what is, we look at what? The equation. Here we must look at the least squares regression line. We can see that it has a negative what? Gradient. So it means that the correlation coefficient is closer to -1 because our gradient here is -3x. Okay. So it is closer to -1. And then what is the reason? You can say the gradient is negative. The gradient is negative, or we can say relationship is indirect. So it's because the gradient is negative, or you can say the relationship is indirect. That's the gradient that they gave us here on the line is 49 minus 3x. So our m here is equal to -3 on this line, the line that we're given. 2.3. They say if a line of best fit is used, If a line of best fit is used, would it be perfectly accurate? Explain your answer. Would it be perfectly accurate? So the answer here is going to be no. Okay. What is the reason? For the line to be perfectly accurate, it means that the correlation should be what? -1. If it's a negative correlation, it should be -1. Okay. So the short answer here is that what? The correlation is not exactly is not exactly -1. So that is why it cannot be perfect. 2.4. Okay, 2.4. Let me do it here. Let's do it this side. They say an individual predicts that if x has a value of 30, y will have a value of -41. However, his friend explained that he is extrapolating and that his result is inaccurate. Explain what his friend is referring to. So, okay. So he's saying that his value of x has a value of 30, y will have a value of 41. X has a value of 30, y will have a value of 30. And then his friend explains that he is extrapolating and that his result is inaccurate. Explain what his friend is referring to. So we can see on our equation there, and we have an outlier of 9 and 4, then 49 minus 3. Okay. So okay, here is because what? His value of x is outside of the lowest and the highest values of x, the lowest and the highest values of x used to find the line of best fit. Line of best fit so it is hard to tell if it is accurate. So this is what I think his friend is referring to. Okay, because the value of x that he used here is 13. See? And maybe that's why the thing is why the friend is saying that it is inaccurate. Okay? He is extrapolating, okay? And the value of the result is inaccurate. It could be because it is outside of the range of the values of x that were used to find the line of best fit here. Okay? So I hope that makes sense. Okay, guys, if you don't understand, you ask your questions in the comment section and I'll explain further. Okay, if you don't understand something. So let's move on to question 3. Question 3 here, they say in the diagram below, PQR is a triangle with vertices P, -5 and -3, Q, -3 and 3, and R, 5 and -3. Okay. Now, okay. Here they say calculate the length of QR. The length of what? QR. Okay. So we have to find the distance. 3.1. We have to find the distance. So QR will be equal to the square root of x cubed QR. X cubed minus xr minus xr y cubed minus yr. So then we have to find the values here. X cubed plus -3 minus 5. -3 minus 5 all squared plus, and then again we go to Q and R. It's going to be 3 minus -3. Okay. 3 minus -3. And then so equals to square root 100, then equals to 10 units. You use a calculator here. Equals to 10 units. 3.2 determine M, the midpoint of QR. Okay, so we must go to QR and find the what? The midpoint. So midpoint x2 plus x1 over 2, and then y2 plus y1 over 2. So equals to So in this case, we can either say, so it's going to be 5 plus -3, and then over 2, and then -3 plus 3, and then over 2 equals to. And then you use a calculator here. Determine the equation of the line passing through P and M. Okay. Determine the equation of the line passing through P and M. So meaning that it passes through the midpoint here somewhere, so that that line passes through P and M there. Okay. So we have to find the gradient of that line. And that's the first thing. So now we have the coordinate is 1 and 0, okay, for M here. So we have 1 and 0. And then so it's x1, y1, and then you have x2 and y2. So in it, we can find the gradient. So we start by finding the what? The gradient. Yeah. So then the gradient for PM will be equal to y2 minus y1 divided by x2 minus x1. So then we substitute we substitute the values. We get the values from there. So y2 minus 1 is going to be 0 minus what? Minus -3. 0 minus -3. 0 minus -3. And then x2 minus x1. x2 minus x1 here is going to be 1, and then minus -5. 1 minus -5. 1 minus -5. And then you use a calculator. You just press your calculator. It gives me 1/2, gives me a half. And then in order to get the equation, what must happen? Y minus y1 equals to m into x minus xy. So then we can take any two values here, okay? We can take any two values. So we can use the values for m. We can use the values for m here, 1 and 0. So x is 1 and y is 0. So it's going to be 1 minus 0 equals to our m. We just found it here, 1/2. And then x minus 1. So therefore, y equals to, and then you multiply inside here. We have x minus 1/2. Or you could use the other values as well. Okay, you could use the other values for P. We could say, if we say, we could do the same thing, y minus y1, and then m, and then x minus x1. So we could use the other values for, instead of using m, we could use p here. So our x is -5, okay, and our y is -3. Yes, our y is -3, -5 and -3. So it's gonna be y minus -3 equals to 1/2 into x minus -5, like this. So then our y would be equal to y plus 3. And then we can rearrange the equation. We then can say, therefore, y equals to half x plus 5/2 and then minus 3. So it's equal to half x, and then you use a calculator here. You use a calculator. It's going to give you 1/2. Oh my God. So we get the same equation. So it doesn't matter. But as long as your substitution is correct, it doesn't matter which point you use, because it is on the same line. So that's why we get the same answer. Okay. Now let's move on to 3.4. Determine the equation of a circle that has QR as a diameter. The equation of a circle that has QR as a diameter. So if it has QR as a diameter, what does that mean? It means that it's gonna have M as a center. So the center is gonna be 1 and 0. That's what it means. So it means that the center for 3.4, what we know, the first thing that we know, is that the center is what? Is 1 and 0. That's what we know at this point. So then we also know that what? We find the length of QR. Yes, we did, isn't it? We did find the length of QR, which is 10 units. So it means that the radius is going to be what? 5. It means we know that QR. We know QR equals to 10 units. Yeah? So if QR equals to 10 units, it means therefore radius equals to 5 units, because we calculated QR, the first question, 3.1, they wanted the length of QR. Now they're saying that the circle has the diameter QR. It means that our R is going to be 5 units. So it means that therefore the equation of a circle, if our center is like this, It's going to be x minus 1 squared plus y minus 0 squared equals to, and then r squared is going to be 5 squared. So then it means therefore it's going to be x minus 1 squared plus y squared equals to 25. Or we can just say x minus 1 all squared plus y minus 0 all squared equals to 25. That is the equation of the circle that we have here. And then 3.5, what do they want? They say, does the point P lie inside or outside the circle in question 3.4? Motivate your answer with relevant calculations. Okay, let's set the point P. Okay, we have to calculate, isn't it here? The circle will be like this. The circle passes through. So in order to find whether the point P lies inside or outside the circle, we have to calculate the length, what? PM. We have to find PM. And then if PM is greater than the radius, then it means that it's outside. Okay. If PM is less than the radius, then it means it is inside the circle. Okay. That's what it means. Okay. So we have to find PM here. We have to use the what? The distance formula. Okay. So PM is going to be 1 and 0, -5 and -3. So we find PM for 3.5. Yeah. Yes, we find PM. So for 3.5, we have to find PM. PM equals to square root of XP minus XM all squared plus YP minus YM all squared. So then it's gonna be, so we take the X values. And then for P, the X is what? So it's gonna be -5 minus 1. -5 minus 1 all squared plus -3 minus 0 all squared. Zero all squared. No. So it's gonna be, you use a calculator here. It gives me a square root of 45. And then in decimal form, it gives me 6.7, which is greater than 5. So this is greater than 5. Okay. and which one is the radius. So 6.7 is greater than 5, you see. So what that means is that PM, it lies outside the circle. Remember what I said here? That we must find PM. If it's greater than R, it is outside the circle. If it's less than R, it is inside the circle. Okay. So this means therefore, yeah. So therefore, point P lies outside the circle. Lies outside the circle. And then 3.6. What are we required to find for 3.6? Determine the coordinates of S if PQRS is a parallelogram with S in the first quadrant. Okay, PQRS. Okay, so it's gonna be PQRS. Okay, with S in the first quadrant. Okay, so it means that if it's a parallelogram, it's gonna be something like that, and then S is gonna be somewhere there in the first quadrant. So what does that mean? It means that the opposite sides are equal if this thing is a parallelogram. Okay. So then what does that mean? Okay, and then the diagonals are also what? The diagonals are gonna be like this, and the midpoint is gonna be there at M here. Okay. So this is gonna be the midpoint. The midpoint for Q and S. Okay. So the midpoint is 1 and 0. So the midpoint for M, okay, we know that the midpoint is going to be 1. So now the x coordinate, well, in order to find that, we're going to say 1 equals to x p plus x s, and then over 2. And then the x and then the y coordinate, we're going to say 0 equals to xp, not yp, sorry, yp plus ys, ys all over 2. So it means therefore 1 equals to, and here we say therefore 0 equals to. Then xp, xs, we don't know what xs is. Then x for p is gonna be what? It's gonna be -5. -5 plus xs over 2. So it means therefore 2 equals to -5 plus xs. So it means therefore xs is gonna be 2 plus 5, which is gonna be 7. Okay? And then YP, YP, negative 3. It's negative 3, negative 3 plus the Y for S. So it means therefore negative 3 plus YS equals to 0. So therefore YS equals to 3. So it means therefore S is what? Is 7 and 3. These are the coordinates of S. Okay. Okay, let's move on to 3.7. Calculate the size of QPR. 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 So it's this angle here. QPR is this angle. So now we have to find the gradient for what? For PQ. Okay. We have to find the gradient for PQ because then we're going to use tan, isn't it? We're going to use the tangent. We're going to say, we're going to use this equation. Tan theta equals to M. So we have to find M first. So here, 3.7. Tan theta equals to M. So equals to y2 minus y1 all over x2 minus x1. So then we must find the values. So we minus the y values first. It's going to be 3 minus negative 3. 3 minus negative 3. And then divided by and then negative 3 minus negative 5. Negative 3 minus negative 5. And then you use a calculator here. You use a calculator, then it's going to give you a value. Then we say therefore theta will be equal to the second function, okay, of whatever value we have here. So our calculator here gives us 3, and so it's the second function of 3 and then again you use a calculator here. So the second function, it gives me 71.57 degrees. So this is equal to Q angle PR. Yes. So that's the end of question 3. Okay. Again, if you don't understand something, you are free to leave the comments in the comment section, okay, and answer and ask your questions, okay. So let's move on to question 4. So question 4 we have, they say in the diagram B, -1 and 1 is the center of the circle. CA is a tangent at A. C is the point -1 and 26. C angle BA equals to A. C angle BA equals to A angle RO equals to theta. Okay, so CA equals to 20 units. Okay, CA is equals to 20 units. So, okay, what do we see here? We see that these two, they are parallel to each other, okay? There is a parallel relationship here. CB is parallel to the what? To the y-axis, because why? We have a -1 here. You also have a -1 there, okay? So this is -1 and 1, and that one here is -1 and 26. So they have the same value of x. So it is parallel to the y-axis, you see. So now where do we go from here? Calculate the following, the length of the radius of the circle. Okay, the length of the radius of the circle. Well, they gave us CA, isn't it? They gave us CA. They say CA is 20 units. Né? So CA is 20. So from here to there, which is going to be equal to A, is it? Is it going to be equal to AB? No, it's not going to be equal to AB. And then what we also know that, isn't it? We know that CB is how much? It's 25 units, isn't it? Because we have a 1 here, so you have to count from 1. It's because of the coordinates. We have the coordinates here, we also have the coordinates here. So calculate the length of the radius of, you can use Pythagoras for 4.1. We can use Pythagoras for 4.1 because we have CA. They gave us 20 units, and CB we can see because it's what? It's 25. So now if we want, it's 25 here. Okay, so if we want, so we can say CB squared, CA and AB. So CB, CA, AB. So we have a square, a square, a square. So AB is the radius. So it's going to be a plus here. So if we want AB, we just have to change the subject here. It's going to be CB squared minus CA squared. And then you use a calculator. So we just change the subject, and then from there, you use a calculator. It gives me 15 units. Equals to the radius, equals to the radius of the circle. Yes. Then the equation of the circle. Well, isn't it? We have the coordinates of the center is -1 and 1. So the x is -1. Okay, the equation of the circle here is gonna be, we use what we have. So then it's gonna be x minus -1 squared plus y minus 1 all squared equals to 15 squared. And then y minus 1, and then 15 squared is 225. 225. Then let's go to 4.3. So 4.3, what are we required to find for 4.3? They say the equation of the tangent CR. Okay. The equation of the tangent CR. Oh, CR. Okay, we know the coordinates for what? For C. Do we know the equations for the coordinates for A? We don't know them. Okay, we know the length. We know what the length is. Okay. We know that the gradient will be given by the tan of what? Of theta, isn't it? So for 4.3, we know that the gradient given by the tan of theta. So gradient, we can find the gradient using the what? Tan of theta. Tan of theta is equal to what? Is opposite over what? Over adjacent. So then we can go inside the opposite of this, because remember this angle is equal to that angle. We must remember that these two angles are equal. So we can find the tan here. Opposite is 20 over 25. So opposite over adjacent. Right? No, it's gonna be 20 over 15, because this is the what? This is the hypotenuse here. So this is the hypotenuse. 25 is the hypotenuse. So it's gonna be 20 over 15. So the adjacent is 15 in this case. It's gonna be 20 over 15. And then, so then from there, this gives us 4 over 3. So there is our what? Our gradient. So then we can go to the equation y minus y1 equals to m and then x minus x1. Then we can substitute what we have. Y minus something equals to, and then 4 over 3 into x minus something. X minus something. Y minus y1. Okay, so it's going to be minus 26. Y is 26. X is negative 1. So it's 26 and then negative 1 here. Then, so it's going to be therefore y equals to 4 over 3x plus 4 over 3 and then plus 26. So you just use a calculator there. So this is going to be 4 over 3x plus gives me, then plus 26 gives me 91 over 3. Or 92, sorry, over 3. So it's 92 over 3. So that's our equation. And then 4.4. What are we required to find? 4.4. 4.4, they say the equation of the radius AB. The equation of the radius AB. Okay. Okay. We know that these two things, they are perpendicular at this point. Okay. At this point, they are perpendicular. And then we also know the equations for the coordinates for B. So we can use the gradient to this side to find, we can use that perpendicular component because we know our gradient here is 4 over 3, isn't it? So then here we can say M1 multiplied by M2 equals to negative 1, okay? Perpendicular lines. So therefore, 4 over 3 M2 will be equal to negative 1. So therefore, M2 will be equal to negative 3 over 4. So we use the perpendicular lines here. So then we can come back to our equation in order to find, so y minus y1, y minus y1 equals to m, and then x minus x1. So then it's going to be therefore y minus something, and then negative 3 over 4, and then x minus. So we go to the center. We go to the center of the circle here. It's what is negative 1 and 1, okay? So it's negative 1 and 1. So it means therefore y equals to negative 3 over 4x, and then minus 3 over 4, then plus 1. And then we go down. So then our equation is negative 3 over 4x plus 1 over 4. You add the 2 here. You get plus 1 over 4. So this is the equation of the line AB here. This is the equation of the line AB, the radius of the circle. Equation of the radius AB, yes. The coordinates of A, 4.5. We want the coordinates of A. Okay, we can, because A, this is where the two lines are intersect each other. Okay, so we can equate the two lines to get the x values. So we can equate the two lines and we solve for x. So we get the two lines for yes. So for 4.5, we get the two lines. We equate the two lines together. Okay, let me try to do it this side. So we get negative, and then 3/4, and then plus 1/4. It's going to be negative 3/4 plus 1/4 equals to, then 4/3x (92/3). So this is 4.5. And then 92/3 plus 1/4 equals to 4/3x plus 3/4x. So then you add the two. Okay, wait, do we have, is it minus here or is it plus? Well, the equation here is plus, okay. It's plus, so it's going to be minus this side. So then it's going to be 1/4 minus 92/3 equals to, so you use a calculator here. you add the two fractions here. 4/3 plus 3/4. It gives me 25/12x. Okay. So then you're going to say therefore x equals to, and then you take the reciprocal here, you're going to say 12/25. Okay. And then you multiply into 1/4 minus 92/3. So then it's going to give you negative 13. Okay, so you use a calculator there. It gives you negative 13. And then you're going to take negative 13. You can substitute anyway. You can substitute negative 13 on the left, or you can substitute it on the right. Okay, it can be on the left or the right to find the y value. Okay, so let's take the one on the right. Okay, it's gonna be 4/3, and then you substitute negative 13. and then plus 92 over 3. And then you just use a calculator here. You just use a calculator. You just use a calculator, then it gives me 10. Okay, it gives me a y value of 10. Then so x value equals to n, and y value equals to 10. So these are the coordinates of, so it means therefore a, if they want the coordinates of what? Yeah, they want the coordinates of a. So a is negative 13 and 10. These are the coordinates of a. It's an intersection point. So we just equate the two. So that sums it up. Question 4. Okay, I think we can move on to question 5 now. Let's move on to question 5. They say solve 5.1. Solve if tan theta is 8 over 6 and theta is between 0 and 90. Show that 10 sine theta plus x equals to 6 sine x plus 8 cos x. So then what we must do here, they gave us theta, isn't it? They gave us theta. If tan theta is 8 over 6, okay, then tan theta is 8 over 6. So this values is y and x, okay, because tan is y over x. So we must find r. You know that r squared equals to x squared plus y squared. So therefore, r is going to be equal to 6 squared plus 8 squared, and then square root. So you use a calculator. The square root of that. R gives me 10. Okay. So we have x, y, and then we also have r. Okay. And then we go away. 10 sine theta plus x. Okay. So okay, if this, and show that 10 sine equals to 6, okay, then it means that, so the left hand side here, so the left hand side will be equal to 10 sine theta plus x sine theta plus x so equals to 10 then sine theta cos x plus cos theta sine x. This is the expansion formula. These are compound angles. So then it's gonna be 10 and then sine is what? Is y over r and then cos x plus cos is x over r and then sine x. So it's 10 into y over r, which is 8 over 10, 8 over 10 cos x plus 6 over 10 sine x. Eight cos x plus 6 sine x. So the 10 will cancel out, and this is equal to the right hand side. So it's 8 and 6, yes, which is equal to the right hand side. And then 5.1.2, what do they want? What are we required to find? So now for 5.1.2, they say, hence, solve the following equation. 6 sine x plus 8 cos x equals to 9. Okay. So for 5.1.2, okay, so they say x is between 0 and 360. Okay, if we say 6 plus 8 cos x, 6 sine x plus 8 cos x equals to 9. It means therefore we can say 10 sine we can say therefore 10 sine theta, we can say 10 sine theta plus x equals to 9. But then we can find theta, isn't it? We can find theta, because we know that sine theta equals to 8 over 10. Okay. Or we can say cos theta equals to 6 over 10. So cos theta equals to 6 over 10. So it means therefore theta equals to 6 over 10. We take the second function of 6 over 10. Okay, so we can find, so then it's gonna be, you use a calculator, yes, then it's gonna be and then it gives you 53.13 degrees. So therefore, sine theta plus x equals to 9 over 10. So it means therefore theta plus x equals to sine second function 9 over 10, and then or because we have to take it in two quadrants. Sine is positive in two quadrants, in the first and the second quadrant. Which means what? Which means therefore x equals to minus cos, and then 6 over 10, then equals to, or we can say 180. So it gives you, so you use a calculator then. Gives me 11.003, or if we go the other side, we can say therefore theta plus x equals to 180 degrees minus sine 9 over 10. And so it means therefore x equals to 180 degrees minus sine 9 over 10, and then minus theta. So equals to 180 degrees minus sine -1, and then 9 over 10, and then minus theta, which is equal to the second function 6 over 10. So cos and then second function 6 over 10. So guys, I hope you are following here, because these values, I'm just getting them from. So we have two answers here. This is from the what? From the first quadrant, isn't it? This is from the first quadrant. And then the other answer, where we say or, is from where? It's from the second quadrant, because that's where sine is positive. Okay. Second quadrant. So we did the two quadrants. So all the other values, I'm just getting them from the top. Okay, the second function here for both cos and sine, along with their numbers. Okay, so yes, it comes from here. So then x will be equal to So it gives you 62.71 degrees. So we've done it here. And then let's go to 5.2. They say we must simplify. Okay. So it's cos 90 plus x, and then cos. So 5.2. We have cos 90 plus x, and then we have cos 90 plus x, and then okay, x minus 180 and tan x minus 180 degrees and tan 360 plus x cos 240 tan 225. Tan 225 degrees equals to, and then we must simplify. Okay, so cos 90 plus x is going to give us a co-function, isn't it? So it's going to be negative sine x, and then x minus 180 is going to give us negative cos x, and then tan 360 plus x is going to give us tan x. Okay, so and then below, okay, what 240 is the same as what cos 180 and then tan 45 degrees. And then here we have the negative will cancel the negative. So you have sine x cos x, and then the tan will be sine x over cos x. And then at the bottom, we have 180 plus 60. It's going to be negative cos 60. It's in the third quadrant here. Cos is negative. So it's negative cos 60 degrees. 180 plus 45. So the tan is positive here. It's in the third quadrant. So it's going to be tan 45 degrees. So these are special angles. 45 and 60, these are special angles, okay? And then at the top, we have what? Sine squared x plus the cos. We'll cancel the cos. And then divided by cos 60 is negative 1 over 2 multiplied by 1. So then at the end of the day, our final answer here is going to be negative 2 sine squared x. -2 sine squared x. Okay, so let's move on to 5.3. So 5.3, so prove the identity 1 plus cos 2a divided by cos 2a. So equals to tan 2a over tan a. Okay, let's begin with the left hand side. Okay, so 5.3 we're required to prove the identity. So the left hand side, we begin with the left hand side, is going to be divided by cos 2a. So divided by cos 2a, so 1 plus cos 2a. 1 plus cos 2a. Okay. So if we simplify, you can try to simplify the left hand side. Okay. If we change cos 2a here, we can say 1 plus 2 cos squared a minus 1 divided by 2 cos squared a using the double angles. Okay, we can use the identities here for the double angles, and then at the top we're left with 2 cos squared a. Okay, so this then becomes 2 cos squared a, first the 1 will minus the 1, and then 2 cos squared a minus 1. Okay. And then the right hand side. Okay. The right hand side of the equation, we have tan 2a over tan a. Tan 2a all over tan a. Okay, so this is equal to tan 2a divided by tan a. Okay, this is the same as sine 2a all over cos 2a divided by sine a over cos a. So then this is the same as if we remove the division here, we can replace the division with a multiply, isn't it? Over cos 2a multiplied by cos a all over sine a. So then this is going to then be equal to 2 sine a cos a divided by and then multiplied by what? Cos a, and then this is 2 cos squared A minus 1, and then multiplied by sine A. So then you will be left with, because sine A here will cancel out sine A. So then you will be left with 2 cos is cos A multiplied by cos A is cos squared A, and then divided by 2 cos squared A minus 1. So it means therefore the left hand side is equal to the right hand side, because we just show that they are. We've just shown here. So yes, sometimes guys, you are required to simplify both sides, you see, such that you get equal values. You see, you get cases like this where you're required to simplify the left hand side, and then you are also required to simplify the right hand side. Okay. Now let us move on to 5.4. Then 5.4, what do they want? If sine 32 degrees equals to t, determine sine 16 in terms of t, okay? Sine 16 in terms of t. Okay, so isn't it sine 32? It can be broken down. So that's 5.4. Yes, 5.4. Well, sine 32 can be broken down into so now we can say we know that sine 32 degrees equal to 2 sine 16 degrees cos 16 degrees. So then if we want sine 16, then we're going to say sine 32 degrees divided by 2 cos 16 degrees. Okay, now equals to 2 sine, no, equals to sine 16 degrees, sorry. Equals to sine 16 degrees. So then how can we express cos 16? Well, we know that cos 32 degrees is equal to 2 cos and then minus 2 cos squared minus 1. So it means that if we say cos 32 degrees plus 1 is equal to 2 cos 16 degrees. You see? So it means that therefore sine 32 degrees all over cos 32 oh no, this is a square, okay? This is a square here. Okay, then it means that if we divide by 2, it's gonna be cos 32. Sorry, let me erase here. It's gonna be a square, so it's gonna be cos 32 degrees plus 1 all over 2, and then cos 16. See, we took out the square here, cos squared, and then 16 degrees. So then the cos 16 is the same as this. So then it's going to be 2, and then square root of cos 32, and then plus 1 over 2 equals to sine 16 degrees. So then we can change the 32 here. We then can say, therefore, sine 32 degrees divided by 2, and then cos 32 is going to be sine squared 32 minus 1, okay, and then plus 1, and then over 2, and then there is a bigger square root here, equals to sine 16 degrees. Oh no, this is 1 minus. This is 1 minus, yes. So it should be the other way around. It's 1 minus sine squared 32. That gives us 32 here. Okay, so now then this gives us then we can substitute, then we can say therefore sine 16 degrees equals to 2, and then 1 minus t squared plus 1 all over 2, and then t on top. There we have t. Yes, we just substitute everything else there by t. We just substitute wherever we see sine 32, okay, because that's what they told us. So that's it for 5.4. If you missed something, okay, you let me know. If you missed something, you let me know here. I'll explain it. You let me know in the comment section. Then let's go to 5.5. Okay. So 5.5, let's go to 5.5. No, let's go to 5.5. Now the left-hand side is going to be equal to cos x plus y minus, so it's cos x plus y and then cos x minus y. Cos x plus y and then cos x minus y. So then it's equal to cos x cos y plus cos x cos y plus minus, or it's going to be minus according to the identity, cos x cos y minus sin x sin y. So it's going to be cos x cos y plus sin x sin y. So then we multiply. So it's going to be cos x cos y minus sin x sin y. So it's cos y here. So it's cos x and then cos y and then minus. So we multiply the negative here. Minus sin x sin y. So then it's going to be negative sin x sin y minus sin x sin y. So then it's equal to negative 2 sin x sin y. Okay. So which is equal to the right hand side of the equation, which equals to the right hand side. So we can leave it there. It was proven. So then in 5.5.2 they say, hence deduce that cos A minus cos B equals to negative 2 sin A plus B over 2 and then sin A minus B over 2. Okay. Okay, so they say what? Cos A minus cos B. So cos A minus cos B. Cos A minus cos B. Okay. We can do it as, if we look at the pattern above, okay. If we look at the thing, we can say cos A plus B over 2 and then plus A minus B over 2 and then minus, and then we say cos A plus B over 2 and then minus A minus B over 2. So then, according then to the equation above that we just proven, this means that then this thing is equal to -2 sine a plus b over 2, and then sine a minus b over 2 is according to the then it is according to what we just proven here, this over here. We're following that. See. So, okay, that's it for question 5. Let's move on to question 6 now. So here we have trigonometric graphs. Okay. We have to look at the trigonometric graph here. They say in the diagram below, the graph of f of theta equals to p cos theta plus q is sketched for from -270 until what? Until 270. -270 until 270. So they're asking, write down the amplitude of f. Okay, the amplitude of f. So the amplitude, isn't it? We have to look at the lowest value, which is -1, and then the highest value. So it's going to be 3 minus -1, which is 4, then divide by 2. Okay, so the amplitude here is going to be 2. The range is going to be from -1 until 3, isn't it? So you can say y is the element of until 3, or you can say y is the element of -1 until 3. That's how it's going to happen. Write down the values of P and Q. Okay, so P and Q. We know that P is the what? Isn't it P is the amplitude of the graph? P tells you something about the amplitude. Okay, and then Q is the vertical shift. Okay, so this graph, if it has an amplitude of 2, it means it has moved by 1 unit up, because if it has an amplitude of 2, it should end here at 2, and then it should come like that on -2, and then it should go to 2 again. That's how it should be, isn't it? But then it means that it has moved up by 1 unit, you see. So we can tell what Q is already. Q is equal to 1, and P is going to be equal to what? It's not going to be 2, isn't it? Because if it was 2, then it means the graph should be going like this. You see, the graph should be going like that and passing at 2. But then it doesn't. It is upside down, so it means that P is negative. It's not positive. See, so it means our P here, you may be tempted to say P is 2, but P is not 2. P is going to be negative 2 because we can see that our graph is what? Is upside down. A graph should be facing up at this point, but it is going upside down. The graph, of course, should begin at 1 and then it should go like that. It shouldn't begin at -1. See, because if it begins here, it means that the P is now less than 0, meaning the P is negative. You see. And then 6.4. Let's go to 6.4. What is it? On the same set of axes, sketch the graph of g of theta equals to -2 tan theta for 0 from -270 until 270. So it means that on the same system of axes, meaning on this system of axes, we have to have what? -2 tan theta. Okay, we can start with the asymptotes, isn't it? Yeah, we can start with the asymptotes. So let us use an eraser here. Let us use an eraser. So the asymptotes, where are they going to be? You may so the asymptotes are going to be at 270. There's going to be an asymptote here, meaning the line that the graph never touches. And then at 90, there's also going to be an asymptote. And then at -90, there's also going to be an asymptote. And then at -270, there's also going to be an asymptote here. And then if it's -2, it means that the graph is going to be upside down, okay? We know that the graph should go like this, okay? It should go like that. But then if it's negative, it's going to go the opposite way, okay? If it's negative, it's going to go the opposite way. So meaning we remove that line and it's going to move something like that. Then it's going to pass at the origin. and then it's gonna go like this, and then it's gonna do the same thing everywhere by there. Okay, so it's gonna be the same way. And then it's gonna do the same thing here. It's gonna do this. Yeah, it will look something like that. Yes, this is how it will look like because it's negative. So yes, this is what it would be. Okay, that is the graph of -2 tan theta, and then it's from -270 until 270. So there will be four asymptotes in that range. So there will be an asymptote here, an asymptote here, an asymptote here, and an asymptote here. There will be a total of 4 asymptotes. And then 6.5, what do they want? Indicate on the graph using thickened lines the intervals on the horizontal theta axis where P cos theta plus Q will be greater than or equal to -2 tan theta, okay, for Q. And then they say from -270 until 270. Okay. So they say where this is greater than or equal to. It means that this will be on top of that. Okay. You see, this will be on top of that. So we have to go to the graph. Okay. And they say we must use we must use a thickened line. I don't know if this line will be okay. Let's see if we can use this line. Okay, yeah, let's use this line. Yes. Okay, so it will go from, let's see, where it is on top. Okay, so starting from here, starting from 225 here, it is on top. Okay, it is on top here, and then it goes all the way. It goes all the way up to where? Up to here, where it is not on top anymore. Yes. So there should be an open thing. And then another one where it is on top. So it goes from here. When we move from this point, and this point is included here, it is on top until here. Until here. So there's an open thing here. So now from here we go and then we go up to here. It is still on top. And then from there, we go from 135, 135 somewhere here. Okay. And that point is included because they said greater than or equal to. So that point is included. And then we go all the way up to 270. We go all the way up to 270. There will be an open circle here. Yes. So these are the intervals here. See? So that's all for question 6. Question 6, yeah, that was the last question. Again, you can leave your questions in the comment section. You're confused by something, you leave your questions in the comment section. So let's go to question 7. So question 7 here we have 3-dimensional shapes here. They say in the diagram, P, Q, and R are 3 points on the same horizontal plane. PR equals to QR. Okay, PR equals to QR equals to M. Q angle PR equals to X. SP is perpendicular to PQ. The angle of elevation of S from Q is Y. From Q is Y. Express the area triangle PQR in terms of X and M. Triangle PQR in terms of X and M. Leave your answer in simplified form. Okay, we can start by finding what? So PQR, okay, in terms of X and M. Okay. So meaning we have to use the area rule, isn't it? We have to use the area rule. Okay, so what do we know here? We know that if these two sides are equal, so if this is M, it means that also the angles would be equal. So it means also we have M here, we have X, then you have X here. It means you will also have X here because they told us that this side is equal to that side. So it means even the base angles, you see, because it means that this thing will be an isosceles triangle. So if we want to get R here, okay, want to get R, so P angle RQ, so 7.1, we start with P, then RQ will be 180 degrees minus 2x. And then the answer here is going to be interior angles of triangle. Okay, so PRQ, sorry. So this PRQ here, P angle RQ is 180 minus 2x. And then how does that help us? Okay, we use the area rule, isn't it? We use that. So area, triangle PQR will be equal to half QR QR, and then PR multiplied by PR, and then sine R. Yes, it's gonna be this angle. This two is QR and PR, and then sine R here. So then it's gonna be equal to half, then M multiplied by M, and then sine of 180 minus 2x. So then it's gonna be equals to half M squared sine 2x. So it's gonna be equal to M squared over 2, and then 2 sine x cos x. So then the 2 will cancel the 2, and then you have M squared sine x cos x. Yes, so this is it in terms of x and M. Okay, sine, then show that PQ equals to 2M cos x. PQ, where is PQ? PQ equals here. Okay, PQ equals to 2M cos x. Okay, so PQ is the side, is part of a right angle triangle. Okay, part of the right angled triangle. So okay, we can use the cos rule for PQ, and then we use QR and PR. Okay. So 7.2. Yeah. So PQ squared equals to PR and QR PR squared plus QR squared minus 2, and then PR QR, and then cos R. So it means that equals to M squared plus M squared minus 2 multiplied by M multiplied by M cos 180 minus 2x equals to 2M squared minus 2M squared, and then cos, so 180 minus, okay, 180 minus 2x, which quadrant is this? It's the second quadrant, so cos is gonna be negative. Okay, so it's gonna be negative cos 2x. So it's going to be equal to 2m squared plus 2m squared, and then cos 2x. So then it's going to be, if we take out the common factor here, it's 2m, 2m. So then it's going to be 2m squared, 1 plus cos 2x equals to 2m squared, 1 plus cos squared 2x minus 1, 2 cos squared x minus 1, and so it's going to be equal to 2m squared multiplied by 2 cos squared x. So it's going to be 4m squared cos squared x. So then it's going to be, then PQ, then it means therefore PQ will be equal to the square root of 4m squared cos squared x. So this is equal to 2m cos x. So this is how you show it. Okay, we used the cosine rule here. We use the cos rule because the angle that is on the triangle that is on the plane here is isosceles, but it's not a right angle. So that's why we used that. And then 7.3, they say, hence, prove that SP equals to 2m cos x tan y. Okay, SP, so SP is the tower here that stands, okay. So SP is the vertical tower here. So then we can use tan. We can say tan y. We know that the opposite over adjacent. Okay. So tan y here would be equal to SP over QP. Okay. So tan y here. So tan y will be equals to SP over PQ. So then SP, therefore SP will be equal to so PQ then is what? 2m cos x and then tan y, because PQ is 2m cos x. So we just replace PQ there with 2m cos x, because we already proven that PQ equals to 2m cos x in 7.2. So that is the end of question 7. Okay, that is the end of question 7. So let us move on to question 8. So given, they say what? Given a circle with center O, A, B, C, and D are points on the circle. Prove the theorem that states A plus C equals to 180. Okay, so the first thing that we must do here, okay, we must make a construction here, okay, so that we can have the two angles. One and two, okay. So now we know that the angle at the center is 2 times the angle at the circumference. So this means that O1 will be equal to this means that O1 will be equal to 2 angle A. Okay. See, okay, let's do this. Let's do this. O1, so we use O1 and O2. So O1 we use A, and then O2 we use C. Okay, so O1, O2. So this is 2C and then 2A. Okay, so it's yes, O1 use A, and then O2 we use C. Okay, so the reason here is so angle at center is 2 times angle at circumference. Okay, this is reason. So even here it's the same thing. Angle at center will be is 2 times angle at circum. And then O1 plus O2. O1 plus O2 equals to 360 degrees. Angles around a point. Angles around a point. So this means that therefore 2A plus 2C equals to 360. Yes, these are the angles here. So if we divide by 2, then it means therefore A plus C equals to 180 degrees if we divide by 2 on both sides. Okay. So that's how you get it. So this is the proof here. Okay. 5 sentences. It's just 5 sentences, and then you prove the theorem that says what? The opposite angles of a cyclic quad are supplementary. So they add up to 180 degrees. Okay. And then let's go to 8.2. Let's go to 8.2. In the diagram below, a circle is drawn passing through A, B, D, E, and F. A, B, D, E, and F. The tangents at B and D meet at C. B, FD equals to X, B angle FD equals to X, and angle E equals to Y. Yes, angle E equals to Y. So they say, express the following in terms of X and Y, given reasons. B2, okay. B2, where is B2? B2 is here. B2 will be equal to F2, isn't it? Yes, B2 will be equal to F2. So B2 here will be equal to F2, which is equal to X. Okay? And then the reason here is Turncott theorem. Turncott theorem. This is why. And then D4. D4 D4 here. Where is D4? D4 will be equal to okay. D4 will be equal to B2, isn't it? Because these are chords. Okay. These two, D4 and B2, will be equal to each other. So the reason here will be so D4 will be equal to B2, which is equal to X. The reason here is what? So angles opposite equal sides. So these are the angles that are opposite equal sides. Okay. And then C, angle C. Okay, so C is here. So C is just going to be, because you have C here, and then you have X, and then you have X. So it means that you just say 180 minus 2X. Okay. So C here is going to be 180 degrees minus 2X. Minus 2X, sum of interior angles of a triangle. Sum of interior angles of a triangle. So, and then 8.2.4, they want angle A. Angle A is here. A. So we know that because these two, they are opposite, isn't it? Each other. So what do we know? We know that A plus what? Plus Y equals to 180. They are opposite angles of a cyclic quad. So it means that therefore A will be equal to 180 minus Y. Okay, so A here will be equal to 180 degrees and then minus y. Opposite angles of a cyclic quad. Opposite angles of a cyclic quad. So, and then 8.2.5. 8.2.5, they say B1. Okay, B1, where's B1? B1 is here. Okay, B1. So B1 will be equal to A, isn't it? It will be equal to A because these two angles are subtended by the same chord, isn't it? B1 and A. So whatever we got for A, it will be, they're subtended by the same chord. So it will be equal to A equals to 180 degrees minus Y. Whatever we got for A. The reason here is that what? FD subtend, it will subtends equal angles because both of those angles are subtended by FD. You see, FD, which is this chord here from F to D. You see, so those are just short questions. Okay, 1 mark, 1 mark, 2 marks. So the 2 marks in each question, like in each question here, 1 mark is for the answer, and then the other mark is for the reason that you give. You see, so that's why it's 2 marks, 2 marks, 2 marks. It's answer and reason, answer and reason, answer and reason. Okay, so that is the end of question 8. Let's go to question 9. Okay, question 9, we have the two circles inside of each other. Okay. They say what? In the diagram below, two circles touch internally at A. Two circles touch internally at A. AB is the diameter of the larger circle, and AL is the diameter of the smaller circle. S and L are the centers of the circles. Okay, S and L are the centers of the circles. D is the point on the smaller circle. D is the point on the smaller circle, and C is a point on the larger circle. ADC is a straight line. ADC is a straight line. M is a point on LB. M is a point on LB such that MN is parallel to LC. MN is parallel to LC. Okay, so they gave us that information. And then 9.1, they say prove that DL is parallel to CB. Okay, DL is parallel to CB. Okay, so we know that these angles here, they are what? They are 90 degrees, isn't it? Because they are subtended by the what? The diameter. They are angles in a semicircle. So those two angles there. So 9.1, we start here. So ADL, okay. So ACB equals to 90 degrees. Okay. Yes, it's going to be ACB. Then it's going to be ADL. ADL is also equal to 90 degrees. So we also have ADL equal to 90 degrees. Okay. So angles in a semicircle. These are angles in a semicircle. Angles in a semicircle. And then, so this means therefore, DL is parallel to CB. Why? Their corresponding angles are equal. Their corresponding angles are equal to each other. So that's why we say they are what? They are parallel. Prove that 2SD equals to LC. Okay. So okay, so we can so LC here, we can see that this will be equal to, so LC and LA. So LC will be equal to LA, okay? What is the reason here? Radii of the same circle. This is the radius in each case. So it's the radius in each case is the LC is a radius and LA is also a radius, okay? And then we also know that what? So SA also equals to ST, which is also equals to SL. Again, the reason is the same, okay? The reason is the same is what? Is radii of the same circle. Radii of the same circle. So we know that, and then we also know that LA equals to SA plus SL. So yes, because LA is made up of SL and SA. Okay. So then we can Isn't it? We can replace. So it means that it's made of SD plus SD. So it's equal to 2 SD. Because LL equals to SD, SA is also equals to SD. Then let's go to 9.3. 9.3, what are we asked here? So 9.3, they say, determine the value of SL over SB. Okay. No, over SL over AB. Okay. SL over AB. Where's AB? AB. Okay. So AS, here we know that. Okay, let's look. AL. AL. So we know that what? AL equal to LB. Okay. And then AS equals to SL. This is the what? Is the radii. Okay. So this means that therefore SL over AB will be equal to 1 over 4. So yes, so it's 2 marks. Shouldn't be a lot of headache. Okay. Determine the length of LM if AB is 30 units. So they gave us AB. AB is 30 units. So AB 9.4. They say that AB is 30 units. Okay. AB is 30 units. So this means that therefore LB is what? It's going to be 15 units because it's a half, isn't it? Because what? Because they told us that AB is 30 units. So LB is a half. The reason here is because they told us that AB equals to 30 units. So, and then after that, then we're going to have what they told us also is that Bn over Nc equals to 7 over 9. Okay. Okay, so this will mean that okay, yes. So what this means is this, is that therefore we can use the proportionality theorem. Then we're going to say 9 over 16 will be equal to Lm over 15. Okay, this is what? This is proportionality theorem. Proportionality theorem. Then yes, because look at what? Look at Lm, and then you look at what? Look at Lb. Okay, Lm over Lb will then be equal to this here Nc over Nc over Bc. See, Nc over Bc because of the proportionality theorem. Yeah. Then from there we can find Lm. Therefore, Lm would be equal to 9 over 16 multiplied by 15. You use a calculator here. You use a calculator. It gives me 8.44 units. Okay, so yes, that's the end of question 9. Let's move on to question 10 now. Okay, question 10 here. In the diagram below, triangle PQT is drawn. O is the center of the circle and OD bisects PQ, PT. PT is perpendicular to QT. PT is perpendicular to QT. And then OD bisects PQ. OD bisects PQ. Okay, so the two sides are equal. Okay, so prove the following. Angle O3 equals to QPT. Okay. So, okay, angle O3 equals to QPT. So the first thing that we know here is that these two are given. They say that they bisect. Okay. So it's that so for 10.1, we start with what we're given. Okay. DQ and DP. Okay. Is given. DQ equals to DP. Okay. So this is what? This is given. The reason is this is given. Okay. And then what is the second thing that we know? So we also know that what? This OD will be perpendicular to what? To PQ. Okay. So OD will be perpendicular to PQ. The reason is what here? They told us that it bisects. Okay. They say that OD bisects PQ. So we also know that OD passes where? It also passes at the center. Okay. So the reason here is what? Line through circle center to midpoint of chord. This is how we know. So this means that therefore we can look here. This is 90. If it's perpendicular, it means that d1 plus t will be equal to. So it means that therefore d1 plus t, because we know that d1 is a 90 degrees because it's perpendicular, equals to 180 degrees. Okay, so it means therefore, okay, if it's like that, it means therefore PDOT, okay, is a cyclic quad. Okay, so it means that DOTP, this circle here, so it means therefore DOTP is a cyclic quad. Okay, so then if DOTP is a cyclic quad, what does that mean? Okay, it means that O3 is equal to QPT, isn't it? It means that because then O3 is here, it will be equal to that, which is QPT. Okay, so it means that therefore, because it's an exterior angle, it means therefore O3 will be equal to QPT. So the angle here is that is the exterior angle of a cyclic quad. So if you know how it works, it's equal to the opposite interior angle. So it's the exterior angle of a cyclic quad. So this there, we've shown it. And then let's go to 10.2. 10.2, what is going on? They say prove that triangle OPD is similar to triangle PQT. Okay, is similar to triangle PQT. So we just have to show two angles, isn't it? Okay, so we have to. Okay, so they want OPD. Okay, OPD, and then they want PQT. PQT. Oh, okay. It means that we have one angle already. We have shown already that this is equal to that because we've shown that this is perpendicular. So we have one angle already. Okay. So in triangle and triangle. So we have shown in triangle what? OPD, 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 and what? And OPT, ne? Oh, and PQT, yes, and PQT, yes, and PQT. We know that G1 is equal to T, isn't it? We have shown G1 equals to T. Okay? So we have one angle, okay? So this was what proved in 10.1. These two are equal. We proved it, okay, in 10.1. Yeah. So now the second thing that we know that OP, okay, OP equals to OQ, because this is a radius. This and that are equal to each other. Right? So the second statement here, we're going to say what? OP equals to OQ. Radi is the radius in each case. OP and OQ, okay? OQ is here and OP is there, okay? And then what else do we know? So if they are like that, then it means that this angle, because those are the angles opposite equal side, will be equal to, this angle will be equal to that angle, isn't it? So this means that P1 will be equal to Q, isn't it? P1 will be equal to angle Q, okay? So angles opposite equal sides. This is the reason here is angles opposite equal sides. Okay. So then we have shown that two angles are equal. Okay. This we've shown that two angles are equal. We've shown that this is equal to that, and we've also shown that what this is equal to that. So that means that O2 automatically, therefore O2 will be equal to Q angle PT. Okay. Sum of interior angles of a triangle. You see. So it means therefore, if we've shown that they are all equal, it means therefore triangle OPD is similar to triangle QPT, PQT, okay. PQT. That's what it means. So, okay, now Then 10.3, the last question. They say what? Prove the following. OQ multiplied by QT equals to 2PD squared. Okay. So we can use the what? The two triangles that are similar here. Okay. And then we can use the what? The corresponding sides. We can use the what? The corresponding sides of these triangles here. Okay. Okay. So what are we going to say? So we can say OP over PQ, yes. OP here over PQ. OP over PQ will be equal to, and then PD. If we say PD, PD will be equal to what? Will be equal, okay, PD will go with QT, okay. PD will go with QT, then PD, sorry. PD here. We have PD. PD will go with QT. And then, so guys, these are corresponding sides, like corresponding sides of the two similar triangles that we found previously. And then from there, we say OD here. OD will go with PT, yes. OD will go with PT. Okay. So the reason here is that triangle OPD is similar to triangle PQT. So then we can rearrange. Okay. We can take this part here, okay, and then we cross multiply. We cross multiply, then we get what? We say this QT multiplied by OP. Okay. So we get OP dot QT equals to PQ PD. So PQ and then dash PD. Okay. But then what do we know? We know that PD equals to DQ. Yes. What do we know here? We know that PD equals to DQ. Okay. PD and DQ, it was given, isn't it? PD and DQ. Okay. It was what? It was given. in it. In what? In 10.1. Okay. And then what else do we know? We know that PQ equals to 2PD. 2PD. Because PQ, okay, PQ is from here to there. Isn't it? It's from here to there, isn't it? So this here we can say therefore, because these two are equal. See? So this means therefore, okay, let's see. We are required to prove what? QT. So this means that therefore, so this means that therefore, OP times QT equals to 2. For PQ, we can put 2PD. Then for PD, we can put PD. And then so equals to 2PD squared. Okay. Okay. Okay, so this means that therefore OQ and QT equals to 2PD squared, because we also know that what? OP equals to OQ, isn't it? Because they are what? They are they are radius. It's a radius. OP is a radius and OQ is also a radius. Okay, so it was a bit tricky, but it was a bit challenging. So guys, thank you for tuning in. So that is the end of question 10, and that is the end of the question paper as well. It was a total of 150 marks. Thank you for tuning in into Metric Hub, and please leave your questions in the comment section, and let us keep the engagement going. Okay. Leave your questions, please, in the comment section, and I will attend to as many of you as I can. Okay. So stay active in the comment section. Okay. Ask as many questions as you can. Thank you for tuning again into Metric Hub, and good luck with the upcoming exam. Okay. So stay tuned, and we are going to do more question papers. Okay. Bye bye for now, and take care. So stay studying and stay focused.